Hey there, math peeps. This is Mrs. Marshall, and we're going to take notes on graphing other trig functions and harmonic motion. So let's start with the parent functions of other functions, and we're going to graph those. So we're going to start with tangent, and you're just going to draw you a nice little t-chart, just a little coordinate grid, and we want to label it from pi to 2 pi and negative pi to negative 2 pi. All right, when you do these functions, especially tangent and cotangent, you want to start with the asymptotes. Where is the function undefined? And when you think about the unit circle, tangent is undefined at pi over 2, because it ends up with 0 in the denominator, and 3 pi over 2. Well, it's also undefined at those values on the negative side, negative pi over 2 and negative 3 pi over 2. And this is the beginning of our function. The other parts that'll actually give you the graph are these points that intersect your technically midline. And in this case, our midline is the x-axis. And it creates a cubic function that repeats itself every pi. And so this becomes our function as a graph. Notice let's make this one curve a little bit. Notice the tangent function. All of these are going up. So that means they're in a positive direction. So these are going up. They are positive. And the way I think of positive is a big old plus sign. And what else has a big old plus sign? The word tangent. That T in the front looks like a plus sign. And that's how I remember. Tangent is positive and it goes in that direction. The function itself, since it repeats every pi, the period is pi. And that is our parent function. So then we have its inverse, which is cotangent. And the cotangent, since it is an inverse, it opens down, it's negative, and it's a minus sign. The only thing I think of with the minus is the T, the cross part of the T. Other than that, I just remember. Let's zoom back out. And so here's our T. And we want to do it the same way. Start with pi and 2 pi. Negative pi and negative 2 pi. And start with where it's undefined. In this particular case, cotangent is undefined at 0. That will put 0 in the denominator. And pi this time. And so therefore it's undefined every pi. So 1 pi, 2 pi, 3 pi, 4 pi, and the negative direction. And there's our asymptotes. Our points that the tangent function had land in between the asymptotes just like the tangent function did. But our curve goes down just like this. And this is the cotangent function. Can you guess what the period is? Pi. The period is pi. Yet again, because every pi, this sucker repeats. And those are those two functions. Now we want secant and cosecant. Let's do purple. Let's start with cosecant. Why? Because cosecant is the inverse of sine. And sine, remember, that pattern is midline high, midline low, midline. If you remember the pattern for this is how you actually graph this function. So we start out with a T, just like we did with those. And we go pi and 2 pi, negative pi, and negative 2 pi. And now we start with the midline high, do the little pattern. I'm going to put my amplitudes at 1 and negative 1. So midline high, midline low, midline. And then continue opposite direction. And there is my sine function. And if I connect these, make a dotted line, This is my sine function. But guess what? I don't want to graph sine. I want to graph cosecant, which is the inverse of sine. So here's how it works. Your asymptotes, which the tangent and cotangent functions had, are where your function crosses your midline. Yes. So you go off of the parent function so you can get the function you actually want. And there's my asymptotes. And then your curves are the inverse of the loops that are already there. So the loop at the bottom is going down. So then I make my loop for cosecant go up. This loop is going up. So I make my loop for cosecant go down. And they literally are just flips. The loops are just flipped the opposite direction. And this is my cosecant graph. The period for this is, instead of 1 pi, we need the opening up and the opening down. So that means you need 2 pi's. So the period is 2 pi. So it'll repeat itself every 2 pi. And our last one is secant. And that is the inverse of cosine, which is high, midline, low, midline, high. And it graphs and works the same way. We start with our little t, 2 pi, negative pi, negative 2 pi. And I want an amplitude of 1. And let's do our pattern. High, midline, low, midline, high, high, midline, low, midline, high. And I could connect this. This would be a nice little W, because that's how the cosine function works. But I don't want the cosine function. I want the secant function. So my asymptotes are at the same spots they were for the sine or the cosecant, which are at the midline, or where the points touch the midline. And there we go. And then our loops work the same way. They go the opposite direction as they are when it's the parent function or the inverse of that parent function graphed. So we're going to go down for that one, and we're going to go up for that one. Essentially, though, these little dotted lines are not a part of your graph. Only part that you graph are the 5 key points, or the 5 critical points. We do not actually graph these dotted lines for the sine function and the cosine function. And there are your complete graphs. So now let's actually do some examples where we put some shifts and stuff involved. Examples. Or first, to graph, you need to find the amplitude, period, phase shift, vertical shift, and 2 vertical asymptotes. Why do we need to find the 2 vertical asymptotes? Well, just to make sure you know what you're doing, because the asymptotes, they help you to graph in terms of putting them on the graph, but knowing what they actually are is just double checking that you know what you're doing, because you don't have to know what they are to graph it. You just need to graph it and then tell me what they are. So let's do some examples. Example 1. We're going to graph y equals 3 tangent x minus pi over 6. So I'm going to try to go through these examples as fast as possible. I want one of each. So 4 examples. Amplitude, period, phase shift, vertical shift, and the 2 VAs. All right, in this case, our amplitude is 3. Our period is pi because it's tangent. Tangent has a period of pi. Phase shift is right pi over 6. Our vertical shift is none. And here's how you find the 2 vertical asymptotes, sort of. So we're going to do some work. The original function goes from 0 to pi, but that's with no phase shift, with no b. So we go ahead and set the inside part with the phase shift and the b in between the 0 and the pi, and we solve for x. So we can figure out where our function is now going to start and where our function will now end. And we solve this. That goes away. So this is pi over 6 is less than x, which is less than or equal to, and that is 7 pi over 6. That part right there, it is now our starting point for our points. Why is it our starting point for our points? Because this is the tangent function, and at 0, the tangent function begins at the points. Let's do that in yellow. At 0, the tangent function begins at the points. All right, so now let's graph it. That doesn't necessarily mean that's our asymptotes either. We need to graph this picture first, and then we can tell what the asymptotes are. So this is pi, 2 pi, negative pi, negative 2 pi. Extend that a little bit. All right, our amplitude doesn't matter because tangent goes up forever and goes down forever. So that's why I put it in quotes to begin with. Amplitude doesn't matter with tangent and cotangent at all. With cosecant and secant, it does matter, and you'll see a little later on. So we want to start our points at pi's over 6's, but the problem is we don't have our pi broken up into 6's. So let's break it up. 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Oh, we don't need that last one because that last one is the one that's already there. All right, so it's broken up into 6's. And now we want a point at pi over 6, so that's here. And a point at 7 pi over 6, so that's here. And then I want to put an asymptote in the middle of them. Why do I put an asymptote in the middle of them? Because that's how the parent function worked. We had a point, and then we had an asymptote in between the next point on the graph. And so our asymptote will go right here in the middle. But just make sure, the way I make sure is just I count the loops. 1, 2, 3 to get to the asymptote. 1, 2, 3 to get to the other dot. And so I am good to go. And then I count and continue with that pattern. 3 to the next asymptote. 1, 2, 3. And then 3 to the next point. And that would be right there. Same way here. 1, 2, 3 to the next asymptote. And then 3, 1, 2, 3 to the next point. 3 to the asymptote, 1, 2, 3. And then 3 to the point, 1, 2, 3. All right. We didn't have a vertical shift, so we are good to go. We didn't need to move those dots up at all. And now I just graphed my graph. It goes up because it's tangent. And of course, yours should be a little more equally spaced apart than mine. Or when you have an actual graph, you'll be good to go. And this is it. Ta-da! We are completely finished with example number 1, sort of. Now we need those asymptotes. We still need those asymptotes. What in the world are these two asymptotes is the question. Well, it's out of 6, so you know this one is 2 pi out of 6, and it's to the left. So that is the same thing as negative pi over 3. And then this one is 1, 2, 3, 4 pi over 6. I'm just counting the tick marks again, which reduces to 2 pi over 3. And these are our two asymptotes. Could you have done 2 other asymptotes? Absolutely, but those are the 2 I picked, so that's it. We're good to go. Let's do the next example. Example number 2. All right. Y equals cotangent theta plus pi over 3 plus 1. Let's find all those things again. Amplitude, period, phase shifts, vertical shifts, and the 2 VAs, honey. All right. Amplitude is none. Yes, there's no amplitude at all for this one. Yes, honey. But there is a period, which is pi because it's cotangent. Remember, that's cotangent is pi. This is going to go to the left. I almost put right. Left pi over 3. Our vertical shift is up 1. And our two VAs, we don't know what those are, but guess what? We can find them. And this will lead us to the graph as well. Woo woo. So theta plus pi over 3 less than or equal to pi again. Okay. And let's make sure we did pi up here. Okay, yes, we want to make sure. All right, continuing. Minus pi over 3 for everything. Okay, subtract all of that. This goes away, so this is negative pi over 3 less than or equal to theta, which is less than or equal to, well, pi minus pi over 3 is just 2 pi over 3. And this right here, my darlings, is not for the points again, because in this case, cotangent at 0, oh, we did that in yellow before. Cotangent at 0 is an asymptote. So when we do these, this lets us know where our asymptotes are. Yes. So because this lets us know where our asymptotes are, we now know our asymptotes. We don't even have to look at our graph to figure that out. I mean, we still could, but we don't have to because they're right there. And now we just need our graph. So boom, drawing the graph. All right, same thing. Pi, 2 pi, negative pi, negative 2 pi. All right, and we want, okay, we're going to have to go up 1 though. So we want to make sure I go ahead and include that. So we're going to go up 1 to our new vertical shift at 1. And we need to figure out what we're going to count by. We're counting by 3s because our asymptotes are pi over 3. So 1 pi, 2 pi, 3 pi. 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 1 pi, 2. Okay. So now let's put our asymptotes. So negative pi over 3, boom. And positive 2 pi over 3. 1 pi, this is 2 pi over 3. Okay, and we want the dot in the middle. So this is a weird situation. We have 3, but halfway would literally just be right here in the middle. But remember, we want to be on the not the asymptote, on the midline because this thing shifts up. So we want to be here. Okay, same thing, but we want to be 1, 2, 3. There's another asymptote. And halfway would be here. This one, you could keep on going that way, or you can just leave it blank. I'm just going to leave it blank. We're going to go to the left. 1, 2, 3. There's our asymptote. And halfway is right there. And 1, 2, 3. Oh, it's not up there, but it's close enough to being up there. So I'm going to go ahead and put it. And asymptote, or not asymptote, my point is on the midline. I'm going to take these little circles off, though, because these little circles are technically not a part of the graph. That's just me showing my work. Can I leave those up there, though, Ms. Marshall? Yeah, you can, but, the complete graph does not have that, so I prefer you take them off. And this is cotangent, so we're going down. And so this would be our picture. Yay! And we are done. Example number 3. Switching it up, we need to do the secant and cosecant ones. Negative cosecant x plus pi plus 2. Now let's find all the things. Amplitude, period, phase shift, vertical shift, and the VAs. All right. Amplitude. Well, in this case, there is no amplitude, but it does reflect over the x-axis. So just make a note of that so you don't forget. Period is 2 pi this time. Dun, 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 because we have switched it up to a different function. Our phase shift is left pi, and our vertical shift is up 2. And now let's figure out those vertical asymptotes from the graph, because we got to figure out the graph first. So 0 less than or equal to x plus pi, less than or equal to 2 pi this time. So minus pi to everything. Boom, gone. So that's negative pi less than or equal to x less than or equal to pi. Yes, that was easy. So the question is, what happens at 0? Oh, at 0 this time, let's not even put 0. This time, this has to follow the inverse function. And remember, cosecant is the inverse of 1 over sine. So it has to follow midline high, midline low, midline. But remember, this is negative though. So since it's negative, it's midline low, midline high, midline. It would have been that, but because it's negative, it's this. All right, let's graph it. Boom, doing my little T-chart. Okay, we want pi, 2 pi, negative pi. Y'all know the routine by now. All right, and now we need we don't need an amplitude, but we do need to account for this phase shift of being up 2. So I'm gonna go 1. Give me that back. 1, 2, and go up a little bit. 3. 1, 2, 3. All right, here we go. Let's begin. Midline high. Oh, wait, before we do that, let's put in our actual midline. We got to have that because that's where our graph is going to be moving to, you know. So midline, and that begins on the here, center point. Because we are shifting to the left, so it begins here. And midline, okay, begins at midline and it will end at midline, so ends here. All right, so these can be a little tricky, but you know you need 3 dots in the middle. So following the pattern, midline low, so we know we have to go down, and it's going to be halfway. Midline low, midline, so we know we're going to be back on the midline, and then high and midline. And that concludes our 5 points. And then we follow in the same pattern. Midline, low, midline. Well, I don't have any more over there, so I'll go the opposite way. Midline, high, midline. And there is our picture. Remember, don't connect the dots. Just do your asymptotes. Your asymptotes are at those points that intersect the midline. So these are asymptotes right here. And now you do your loops. Your loop should not cross the midline. No, no, no. So that one has to go up and this one must go down. It can cross the x-axis this time because the x-axis is not our midline. And ta-da, dun, 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 we are finished. Last example, example number 4. Y equals 3 secant 2x minus pi over 2 minus 1. Finding all the things: amplitude, period, phase shift, vertical shift, VAs. Oh, speaking of VAs, we didn't find the VAs for the last one. So let's go ahead and do that. 2 VAs, this is very, very easy. Boom, 0 and pi. Very simple. So back to our example. Our amplitude is 3. Our period, is 2 pi over b, which 2 pi over 2 is pi. Our phase shift is pi over 2 divided by b. Can't forget all that stuff. And so this is keep, change, flip. And so that's pi over 4. And that is going to go to the right, pi over 4. Vertical shift is down 1. And now we need to figure out our vertical asymptote / graph this thing. 0 and less than or equal to 2x minus pi over 2, less than or equal to 2 pi. And we are going to add pi over 2. Y'all know what that is. Less than or equal to 2x, less than or equal to, 2 pi plus pi over 2 is 5 pi over 2. Okay, and then we want to divide by 2. Divide by 2, divide by 2, and divide by 2. This goes away. X is greater than or equal to pi over 4, do keep, change, flip again, and less than or equal to 5 pi over 4, keep, change, flip. And this lets us know where to begin our inverse of secant, which is 1 over cosine, which is high, midline, low, midline, high. And in this case, there is no negative, so we just begin in that spot. So let's do our graph. Boom, boom. Okay, so the graph for this: pi, 2 pi, negative pi, and negative 2 pi. All right, let me move this dot over just a little bit. It looks a little awkwardly spaced. Okay, there we go. Okay, now we need an amplitude of 3, but it's also got to go down 1. So we're going to go up 1, 2, 3, and then down 1, 2, 3, 4. I'm going to extend it a little bit more. 5. Okay, let's begin. We want our down 1 right here. Okay. And now we got to figure out what to count by. Oh, the previous one we didn't have to count by anything because it was pies. It was whole pies. This one we got to count by 4s. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. All right. Now let's put in those. Ooh, HM, the pattern. So our high. One more thing before I put in the pattern. Let's figure out where high is. It's 3 up from the midline. So 1, 2, 3 up would mean we would be right here at 2. And then 1, 2, 3 down would mean we would be right here at negative 4. Just want to make sure I know how high up I'm going and how low I'm going. All right, let's do this. High, starting at pi over 4. And then, take that off. And then we want our high ending at 5 pi over 4. So that would be here. And now we got to have those 3 critical points in the middle. High, midline, low, midline, high. And those are it. We just got to keep going in that pattern till we get to the end of the graph. So high, midline, low, midline. I don't have a high over there. And then we continue to the left. High, midline, low, midline. Uh-oh. High. I think I'm good on. Think I'm right. Think I'm right. Yeah, that looks pretty good. Okay. High, midline, low, midline, high, and high, midline. Midline's where we're going to end right there. All right. It looks a little woo, but that's how these graphs end up looking. And now, as long as you've counted right, you're good to go. You can tell when it's off or when it's on. These look a little equally spaced apart. They look pretty good. So now let's do the asymptotes. Asymptotes along the spots where it touches the midline. Okay, gotta keep on going. Boom. Several of these. And then we're gonna go up. Let's put a couple more dots. Just to be a little taller than my graph is actually going to go. This one's real thinly in between here. And this one goes down. Notice no two going up are next to each other, and no two going down are next to each other. Whew, and we're almost finished. Last part is the vertical asymptotes, and we just need two of them. All we need is two of them. And that one, the first one is 0. And then the second one, that's 1 pi to 4, 2 pi to 4. Oh, 2 pi over 4. Oh, that bad boy is pi over 2. And so we have those as my vertical asymptotes. And this concludes the graphing portion of trig functions. I'm going to do a separate video on simple harmonic motion. Make sure to watch the second video. Again, make sure to watch video part 2 now. And Marshall is out.